Welcome to solverfy.
So I have a ladder that is 25 feet long and it's leaning against a vertical wall. That means I have a right triangle. Jack begins pulling the foot of the ladder away from the wall. So this is going to the right, and I'm going to label that distance X. And I want to know how fast the ladder is sliding down the wall. I'm going to label that Y, so that direction is Y. So I'm going to relate these variables. I know that X squared plus Y squared equals 25 squared. I'm going to take the derivative of this equation. That's going to give me 2x dx dt plus 2y dy dt equals 0. Derivative of a constant is 0. Okay, now I want dy dt. I want how fast it's changing vertically. I have dx dt. That is 0.3 feet per second. And now I'm going to need to get an x and a y. So I'm just going to draw a second triangle. The ladder stays 25. And I want to know this rate when the foot of the ladder is 7 feet. So I want that to be 7. So my x is going to be 7. And now I need to get y. So y squared plus 7 squared is 25 squared. So I'm going to get y squared equals 625 minus 49 is 576. Square root of that is 24. So y is 24. Okay, since I want to find dy dt, I'm going to rewrite my equation. So 2y dy dt equals negative 2x dx dt. I'm going to divide both sides by 2y. So dy dt is going to equal negative x dx dt over y. So let's plug in our values. Dy dt is going to equal x is 7, so negative 7 times dx dt, which is 0.3, over y, which is 24. Negative 7 times 0.3, that's going to give me negative 2.1 over 24, which is going to give me a dy dt of negative 0.0875 feet per second. And that's the answer to that problem. Okay, now the next one, I have a circle, and I'm told the area, so I'm going to write my area formula. The area is increasing, so I have dA dt, the rate of change of the area, and that's 2 centimeters squared per second. I want to know how fast the radius is changing, so I want dr dt when the radius is 4. Okay, so again, I'm going to take the derivative of my area formula. So that is going to give me, this is 2, dA dt equals 2 pi r dr dt. Since I want to solve for dr dt, I'm going to rewrite my equation, which gives me dA dt over 2 pi r. Let's fill in. dA dt is 2 over 2 times pi times 4. So dr dt is going to equal 2 over 8 pi. We can do that division, and we are going to get approximately 0.0796 centimeters per second. Now in B, I want to know how fast the radius is changing when the circumference is 4. So this was A. In B, when circumference is 4 centimeters. Okay, so I'm going to use the same formula, dr dt equals dA dt over 2 pi r, and I still have a rate of change of my area of 2, so I'm going to put that in there. So all I need is r. So circumference is 2 pi r. If my circumference is 4, then my radius is 4 divided by 2 pi, or 2 over pi, which is going to give me a radius of approximately 0.6366. So I'm putting 0.6366 in for my radius. Let's do that division. So I want 2 divided by 2 times pi times 0.6366. And that is going to give me 0.5, and that is 0.5 centimeters per second.